Have you ever wondered how your phone recognizes your face? Or how computers make decisions like we humans do? The answer lies in something fascinating: neural networks. But what are they? And how do they actually work? In this video, we'll break it down in the simplest way possible, so by the end, you'll understand how machines can learn and think just like humans. Let's understand it through a simple example. Imagine you're part of a team working on a task to detect if a given image contains a dog or not. Each person in the team has a specific role. Some analyze data, some make decisions, and some finalize the results. Before our team can begin working, we need raw data, the image itself. This image is broken down into tiny pieces of information like color values, edges, textures, etc. These pieces of data are like messages passed to our team members. We have a group of assistants who extract these information from the image. Let's call them Eve, Frank, and Grace. They don't do data analysis, but simply pass these data features forward to the team for further processing. Now, let's meet our main team members: Alice, Bob, and Charlie. They receive input data from Eve, Frank, and Grace. Alice specializes in identifying legs. She looks for four-legged figures. If she detects 4 legs, she outputs 1, otherwise 0. She then multiplies this with a weight value, say 0.5. Initially, the weight values are chosen at random and are refined over time. Bob focuses on textures and checks for fur patterns. If he finds fur, he outputs 1, otherwise 0. He then multiplies this with a weight value, say 0.3. Charlie detects facial features and tries to spot a snout and 2 ears. If he finds them, he outputs 1, otherwise 0. His weighted contribution is 0.2. Everyone then passes their findings to Diana. Diana listens to everyone's inputs and makes a final call by summing up their weighted opinions. If the total confidence score is above a threshold value, she says, "Yes, this is a dog." Otherwise she says, "No, this isn't." For our example, let's take the threshold value as 0.7. Now, there is one more important person in our team: Olivia, the manager. She compares Diana's answer with the input image to determine the correct answer. Based on this, Olivia provides feedback to the team. If Diana is correct, Olivia praises the team and keeps their weights unchanged. If Diana is wrong, Olivia asks the team to adjust their approach by modifying their weights. She may tell Alice to rely less on the number of legs or Bob to increase his focus on fur patterns. This feedback allows Alice, Bob, and Charlie to adjust their weights so they perform better next time. Now, let's say an image of a dog is presented to the team. Eve, Frank, and Grace extract the color, edges, and texture information from the image and pass it to Alice, Bob, and Charlie. Alice sees 4 legs and outputs 1. So she assigns 1 into 0.5 to the total confidence score. Bob detects fur and outputs 1. So he adds 1 into 0.3 to the next stage. Charlie notices the snout and ears and outputs 1, contributing 1 into 0.2 to the confidence score. Diana sum up the scores. The sum is 1, which is above the threshold. So she confidently says, "It's a dog." Olivia compares it with the input image and sees that Diana was right. She then provides her feedback to the team. Now, imagine the team is shown an image of an elephant. Eve, Frank, and Grace pass raw data to Alice, Bob, and Charlie. Alice sees 4 legs and outputs 1, so she assigns 1 into 0.5. Bob doesn't detect fur and outputs 0, so he assigns 0 into 0.3. Charlie doesn't see a snout and dog-like ears and outputs 0. So he adds 0 into 0.2. Diana sum up the scores and sees it's below the threshold value. So she concludes, it's not a dog. Olivia checks the answer and sees that Diana was right again. She again provides the feedback to the team, boosting their confidence. What if the team makes a mistake? Let's assume the weights for Alice was 0.7 and that for Bob and Charlie was 0.2 and 0.1 respectively. Now the sum is 0.7. Since it's equal to threshold value, Diana incorrectly identifies the elephant as a dog. Olivia steps in and corrects the mistake. She tells Alice that relying only on 4 legs isn't enough and asks her to reduce her weightage. She tells Bob and Charlie to increase their weights, since their output was correct. Alice, Bob and Charlie adjust their weights, making sure they don't repeat the mistake. This process continues, and over time, every team member becomes an expert in identifying the features of a dog. Diana can then make a correct prediction by combining individual outputs. So that's it. You just understood how a neural network functions. A neural network works in a similar way to our problem-solving team. It has 4 main parts. The input layer, which receives raw data and passes it along. The hidden layers, which analyze different aspects of the data. There can be 1 or more hidden layers. The output layer, which makes the final decision. A feedback system, which checks the output and adjusts weights to improve accuracy over time. The layers are created using nodes or neurons which perform tasks similar to a team member. Neurons are computational units which can perform a task. Each neuron in a neural network takes in information, applies weights to it, and then passes the results forward. The system learns over time by adjusting these weights during its learning phase, called training. A complex neural network can have n number of hidden layers, which can fine-tune the result. At first, a neural network doesn't know much about identifying objects. It makes a random guess. Might make mistakes. Receives feedback and adjusts its weight, just like how Olivia helped the team to refine their approach. This process is called backpropagation. Over time, the network refines itself, just like how our team did. The more data it processes, the more accurate it becomes. Have you ever wondered why it's called a neural network? That's because it mimics the way our brain processes information. With millions of neurons working together, every decision we make is the result of countless tiny calculations. It's incredibly simple and amazingly complex. Today, neural networks are everywhere. Self-driving cars to voice assistants like Alexa and Siri uses complex neural networks to analyze data and generate insights from it. So, next time you unlock your phone with your face or get a surprisingly accurate movie recommendation, remember, a neural network is working behind the scenes, learning and improving itself, just like we do. Want to dive deeper into AI and machine learning? Let us know in the comments. And if you found this video useful, don't forget to like, share, and subscribe to our channel, where knowledge knows no borders. Thanks for watching, and see you in the next video.